What is up, guys? Coming to you with another video where we are going to be going over heat exchanger maintenance and what we can do to repair and protect those systems and keep them running for longer. Now, something that I haven't said in the last couple videos is everything I talk about is in general terms, so you won't hear me call out a specific or a particular product name, but rather a product type. So whether that's it's a ceramic lining or a ceramic paste or a Novalac epoxy, I'm going to be talking in general terms so that you guys can take this and use it in your day-to-day with whatever manufacturer or supplier you're working with without having to parse through any data and say, what actually was this product? I'm just going to tell you what it is and not necessarily a particular product name, again, so that you can use it in your day-to-day. This information's for you guys. So without further ado, let's jump into it. So when dealing with heat exchangers, our two main modes of failure are one, a fouling issue, or two, a corrosion issue. Now in the next couple slides, we're going to define terms real quick so we're all on the same page, but these are the two predominant ways that they fail. Are there other issues that can arise? Yes, but generally those will fall outside of what we can do with an epoxy. And so with that, we're going to steer more towards the fouling and corrosion side. So without further ado, let's go ahead and define terms and then we'll go on from there. So fouling is going to be any sort of buildup within that system, and most commonly this is going to be your hard minerals or solids that make their way into the system. And for most HVAC or heat exchanger units, the whole goal is to keep that water very low conductivity so we don't have any minerals or solids in it. Now that doesn't always work out because over time low conductivity water likes to pull minerals out of whatever it's in contact with, so naturally we're going to have some buildup there. And also with a lot of these facilities, everything's just so big, things do break here and there, and so solids can be entered into the system, which can cause issues and cause buildup. Now alternatively, corrosion is something pretty common that we already talk about on this channel, but corrosion is just going to be any sort of rusting, pitting, anything like that where we're just seeing degradation of the substrate itself, not necessarily build up, but more a deletion of material, which can cause further issues. So again, fouling is generally a function of hard water and buildup and things like that. And if you look here in the picture, you can see, hey, we still have all our tubes going through there, but we have a lot of buildup there. And what that will do is that will drop your fluid flow or decrease your flow rates, as well as it just causes a worse exchange rate from a heat perspective, right? Because the whole point of a heat exchanger is to exchange heat. And so when you have this buildup, you're dropping that efficiency. So you can drop efficiency from the buildup, you can drop flow rate from the buildup, and combine both of those will actually, double drop the efficiency, which can cause a larger number of problems because now we have two bad actors causing issues. Now with corrosion, plain and simply put, this is going to be degradation of the substrate, which is again something common on this channel, but specific to heat exchangers. The big issue here is not so much that we're messing with heat exchange rates, although that is possible, but more if the corrosion gets bad enough, what happens is we will then get a hole or something that will breach between the process side and our cooling side or heating side if we're heating. But it will cause a breach there, and then we will have a mixing of the two, which is a big problem, especially if we have anything where, hey, we can't have water in there, or we can't have whatever we're heating or cooling in the water because of what we're doing further down the process. That can cause a big issue. But that is the big primary concern with corrosion. And then on the next slide, we're going to go into what happens when we get both of these. So when we were talking about the fouling, right? So fouling can decrease your flow rates or decrease your heat transfer rates, or both, and then you kind of have the double whammy there. With corrosion won't necessarily affect or directly affect your heat transfer rates or your flow rates, but corrosion can affect your fouling rates, because what will happen is as you corrode and you rust, you are going from a smooth surface to an imperfect surface, and if you go to pitting, then even less perfect than that. And what will happen is that will cause fouling to accelerate, which will then cause issues with our flow rates and our heat transfer rates. So the whole goal is to minimize corrosion so that we minimize fouling. Now, in some cases, we might not have corrosion issues, just fouling issues. And in some cases, we may just have corrosion and not fouling. Although, generally speaking, if we have corrosion issues, it will lend itself to fouling issues further down the road. So now the question becomes, how do we prevent this? So generally speaking, let's say we have a brand new unit or a unit that's just been repaired and we want to stop any issues. What I like to do first is apply an anti-fouling lining. And the reason being is, in this case, when we're dealing with fouling and corrosion, as a good rule of thumb, and this isn't always true, so don't hold me at gunpoint to this, but as a good rule of thumb, when we put a anti-fouling lining in, it's naturally corrosion resistant, so we're going to already have a corrosion barrier. And then what the fouling is designed to do, in our case, we're generally going to use a ceramic, a thin film system that's super smooth, is that will stop any buildup from happening or minimize the buildup. And so when we go to do a service on the heat exchanger, one, we may just have no buildup at all or very minimal, something we can wipe down, or two, we can clean it with relative ease, but we didn't affect the underlying material, the sheet or anything like that, to where we don't have any actual repairs to make. It's purely a cleaning. And so that's one of the big benefits of the anti-fouling, is we maintain our flow rates, we keep our heat transfer rates high, or within range of what they should be, and when we go to clean it, all we have to do is clean it. We don't have to clean it and then fix it. It's just a cleaning, and then we're back up and operational. Now, step 2 is more a sub-step of step 1, but I split it up, is if, let's say we were fixing a system where we didn't have any fouling issues, but we had high corrosion issues, we could switch to just a corrosion barrier, which would be a good general purpose epoxy that can handle the water or anything that's in there. And the reason this is split is because if we don't have any fouling issues, we still want a corrosion barrier there to protect that substrate. Again, that doesn't necessarily mean that the anti-fouling lining couldn't also doubles the corrosion barrier. In many cases, people just say, hey, I'm just going to put this in regardless because it is my corrosion barrier. But if you wanted 2 distinct products, we can do one that is to be a corrosion barrier only, and then the anti-fouling one, if that's what we needed, can be both anti-fouling and a corrosion barrier. So the third step here more applies to if we're repairing a heat exchanger. And the whole point of the paste grade ceramic is to fill in any heavy pitting that we have. And this could be a function of fouling, but is most commonly a function of corrosion, where, hey, we didn't have a coating in there to begin with, and now we have a pitted surface that we need to correct. And what this is going to do is 2 things. The first is, when we fill in these pits, we're giving ourselves a nice smooth surface to actually adhere our top coat to, which will then give us our corrosion barrier and give us, if needed, an anti-fouling barrier. But the second thing is specific to anti-fouling. When we smooth out that surface, we are decreasing the overall surface area, because if we look at a smooth surface, let's imagine it was perfectly smooth. If it was 1 foot by 1 foot, that's 1 square foot. But if it's heavily pitted, it's 1 foot by 1 foot, but we have all our ups and downs, which is a lot of area where we can grab material, especially in a fouling scenario, to where that 1 square foot might actually be 5 square feet of surface area. And so the paste grade ceramic is designed to fill in all of those gaps to reduce our surface area where we can foul, and then again allow us to put on a top coat that is perfect so that we don't have any 1, corrosion issues, or 2, fouling issues. So now the last question is, what do we do in a worst case scenario, or what is the worst case scenario? So for us, worst case scenario is 1, this is a already in service heat exchanger that is experiencing both corrosion and fouling. And so what we have to do is, 1, we have to clean all of the fouling out of that system. And then the second would be, kind of working back in reverse order, would be go with step 3, which is apply a paste grade ceramic. So we prep the surface, we try and get rid of as much pitting as we can, and then we use that paste to fill in all of the pits on the surface. And then the steps kind of 1 and 2 combined would be, let's get a corrosion barrier in and an anti-fouling lining in, which can be one and the same. So for me, I like to use a thin film ceramic lining. And so what that will do is, 1, That will provide a barrier against any corrosion paired with the paste ceramic. And 2, because we now have a smooth surface and we're finishing it with an even smoother thin film ceramic, we're going to drastically reduce the ability for that system to foul. It doesn't mean that we can't have some, but it will drastically reduce it, and again make it so all we have to do is clean it, as opposed to do a full rework on the system every time. We can drastically cut down our overall maintenance of the system and keep things up and running longer. As I always say, there really is no best for these systems. The steps that I gave you is what I work through in deciding what we're ultimately going to apply. In some cases, hey, the best might be I just need a ceramic because it's a brand new system, but the previous one had fouling and we just want to protect it. And the worst case scenario could be it's a 10-year-old system with fouling, with corrosion, with pitting, all of this. And so the best system would be a paste and then have a combination of an anti-fouling lining with a corrosion barrier. So again, there really is no best, like, hey, this is the end-all be-all, but these are the steps I take to work through so that I know what I'm putting down is going to work long-term and keep their maintenance costs as low as possible. So really hope this was helpful for you guys. If you have any questions, drop a comment down below and I will get to you as soon as I can. As always, I appreciate you guys. Take care and Godspeed.